Good morning, ladies and gentlemen, boys and girls, friends and neighbors, or good afternoon, whatever the case may be. Today we're going to start Unit 7, Unit 7, Lesson 1. This is the first lesson here. Unit 7, Lesson 1 is a review of some topics that you talked about back in your geometry class. Nevertheless, very important lesson in our study of trigonometry. The geometric definitions of the trigonometric ratios are fundamental in understanding the formal study of trigonometry. So let's jump right in there. Consider the following right triangle. I have a right triangle here, right triangle ABC, and I'm going to make note here that B is the right angle. Measure of angle B is 90 degrees. The sine of an angle is denoted as the following. Sine of an angle is denoted as the following. Sine of A is defined to be the ratio of the opposite side of angle A divided by the hypotenuse. That is, the sine of A is the opposite over hypotenuse. So in here, for this particular diagram, this is angle A. Let me get my pen. Whoa, get my pen working here. There we go. This is angle A right here. And this is the leg opposite A, and this is always the hypotenuse. This guy right here is always the hypotenuse, H. So the sine is the opposite leg over the hypotenuse, and we can see that this fraction here creates a ratio, hence the name, the trigonometric ratios. Well, and the other thing we want to denote is that this SIN, that's shorthand for sine. We don't say sin of A, we say sine of A. In like manner, the cosine of angle A, which is abbreviated cos of A, but we say cosine of A, is the adjacent leg to A, the adjacent to A. This is the leg or the side that's next to angle A divided by the hypotenuse. So the cosine is the adjacent over the hypotenuse. The sine is the opposite over the hypotenuse, and the tangent of angle A, which we use shorthand TAN, tangent of A, is the opposite leg over the adjacent leg. And all three of these are fractions. All three of these are ratios. Hence the name trigonometric ratios. And the geometric definitions are the foundations of the study of a formal study of trigonometry. So let's do an example and just see what the heck is going on here. Okay, so consider the right triangle. We're going to look at example 1 right here, George. All righty. Consider the right triangle. Sketch the triangle given the following conditions, where triangle ABC, where measure of angle A is 90, AB is 7, and BC is 3, and find AC. So let's do this first. Let's do a little bit of a, see if I can't get this triangle in perspective here. Well, first of all, that is not going to be, get rid of that. Let's get a straight line here where I can have a right triangle. That's not too bad there, Lee. Let's grab that over here. I like things precise, and that's all right. Okay, so here is my right triangle. I think I have it fairly in perspective. This guy here is going to be the B, all right? And AB is going to be 7, BC is 3. That's nice, so I'm going to let this guy here be AB. So that length is going to be 7, and this point there, or that angle there, if you will, is going to be C, and BC is 3. Okay, and now don't get confused that this angle, this point here, we're going to call it A, but we are talking about this angle. This point here is C, but we are talking about that angle C. So that C is going to represent an angle and a point in this case. So I want to find AC. Well, this is going to be easy. I'm going to use the Pythagorean theorem, and I realize that AC is going to be 7 squared plus 3 squared. 7 squared is 49 plus 9 looks like AC squared is going to be 58, and therefore AC is going to be the square root of 58. And as we have noted earlier when we were reviewing Pythagorean theorem, was that we don't have to worry about the positive and negative square root of AC because we are talking about triangles. So the length of that AC, the length of AC is going to be the positive square root of 58. Okay, so now I have my triangle labeled. For the following, find the following for the same triangle using simplified square roots. So I want the sine of A. I want the sine of A, and I might need to look up here and say, oh, what is the sine? The sine of A is the opposite leg over the hypotenuse. Well, the opposite to A is going to be 3, and the hypotenuse is 58. And just 58 is a simplified square root. Do not, and I repeat, do not give that ratio as a decimal. We want that ratio as a simplified radical, as a real number. So what we need to do with that, we're going to need to multiply the top and bottom by square root of 58 to get that 58 out of the bottom, and the final answer here is going to be 3 square root of 58 over 58. And that's the sine of the angle A. In like manner, the cosine of A, which is the adjacent side, the adjacent leg divided by the hypotenuse, is going to be 7 over the square root of 58. I'm going to multiply that by square root of 58 over square root of 58. Looks like I'm going to run out of room here for the tangent, and that is going to be 7 square root of 58 over 58. That's the cosine of A right there, written in red. The sine of A is written in blue. And the tangent of A, the tangent, let's see here. What is the tangent? The tangent, is the opposite leg divided by the tangent, divided by the adjacent leg. The opposite leg, opposite, So the tangent of A, we're going to do this in green, is simply 3/7. Not a lot of room there, but we got it, 3/7. In like manner, let's find, this is a little typo here, and so what I want to here, I don't want to find the sine of B, I'm going to find the sine of C, and the cosine of C, and the tangent of C. Not that we can't find these of right angles, but that's what we're going to learn how to do in trigonometry. So let's find the sine of C, and we know the sine of C by looking at my definition. The sine of an angle is the opposite leg over the hypotenuse. The opposite leg over the hypotenuse. So if I'm looking at angle C, the opposite leg is going to be 7. So this rascal, I'm going to do this in blue as well, that's going to be opposite, which is 7 over square root of 58. Hey, and I already know what that is simplified. Simplified, that's going to be 7 square root of 58 over 58. And that's interesting, that the sine of A is equal to the sine of C is equal to the cosine of A. That is interesting, and that's a property that we'll talk about down the road, not today. Let's carry on and find the cosine of A. And the cosine of A is defined to be, let's see here, the adjacent leg. I'm going to jump up here and look at my definition. So the cosine of angle, any angle, is going to be the adjacent over hypotenuse. Adjacent over hypotenuse. Well, what's the adjacent leg to C is going to be 3. So this rascal here is going to be 3 over the hypotenuse, which is square root of 58. And I already know what that is simplified. That's going to be 3 square root of 58 over 58. And if I want to find the tangent of C, the tangent, looking up here at my definition, these definitions, it's imperative that you know these definitions well. These definitions you will have to memorize if you do not already have them memorized from your study in geometry. Okay, so the tangent is the opposite leg over the adjacent. The opposite leg over the adjacent. The opposite, let's see here. What's the opposite? Is 7. What's the adjacent? 7/3. Okay, so this, when I was copying this for this particular presentation, this is part of the next page. So don't get confused on that. So let's go back in here and review this particular example. So I had an example where I was given the length, I was given a right triangle, triangle ABC, where the measure of angle A was 90 degrees. Pardon me, the angle, measure of angle B, where one leg was 7, the other leg was 3, and I found the hypotenuse, and then I found these 6 trigonometric ratios: the sine of A, cosine of tangent of A, sine of C, cosine C, tangent of C. What we're going to do right now is we're going to diverge from this lesson just a little bit. And if you look to the left of your interactive notebook, you will see a blank page. On that blank page, we're going to talk about 3 other trigonometric ratios. We're going to talk about the cotangent of an angle, the secant of an angle, and the cosecant of an angle. If I can spell cosecant correctly, that's silly. Okay. And again, we're going to have the geometric definitions of these trigonometric ratios. We're just looking at 3 more trigonometric ratios. And I'm not sure if you looked at these trigonometric ratios in geometry or not, but if you did not, we are presenting them to you now. So here I have a right triangle. I have a right triangle. This guy, again, I have right triangle A. Well, this time I have a right triangle. Oh, this is actually good that we're doing this. Right triangle ACB, where C, the measure of angle C, is equal to 90 degrees. And then the angle A and B are the complementary angles to that. And here, I created this diagram similar to how I used to use this diagram in geometry. If I have capital angle B here, this side length AC is going to be lowercase b. And if I have this angle here, A, this pointer angle A, the side opposite A, I'm going to define as lowercase a. And if I let the right angle be 90, then, or if I let the right angle be point C or angle C, then the opposite side of that is going to be lowercase c. And I'm going to now define these 3 new trigonometric ratios. The cotangent of an angle. The cotangent of an angle is abbreviated COT. It looks like cot, something you would sleep on. It's not. When you see the word COT, that means cotangent. And the cotangent of an angle is defined to be the adjacent side of that adjacent leg divided by the opposite. So let's see here. If I'm looking at angle A, it's going to be the adjacent over the hypotenuse. In this case, the adjacent leg is going to be B, and the opposite leg is going to be A. So that's going to be B over A. And it's interesting to note that the cotangent is actually equal to 1 over the tangent. And that is something that you will come to know down the road well as also, is that the cotangent of A is 1 over the tangent. Right now, for the IXLs that you're going to be assigned, or the homework that you're going to be assigned, you're going to need to know that the cotangent of A, the cotangent of an angle, is going to be the adjacent leg divided by the opposite leg. In a like manner, right away, I'm going to tell you, well, hey, what is the cotangent of this angle B then? The cotangent of this angle B, if it's going to be the adjacent to B, is going to be A. The opposite leg to B is going to be little b. That's going to be the cotangent of B. So let's look at the definition for secant. The definition for the secant of an angle, abbreviated SEC, the secant of A, is defined to be the hypotenuse divided by the adjacent side, the adjacent leg. So this is my leg that's adjacent to A, and I have the hypotenuse C, so the secant of this angle right here is going to be C divided by B. And it is interesting to note that the secant is 1 over the cosine of an angle. Keep in mind, I would ask that you can always, as with any video, you can stop the video. This is going to, we're going to check to make sure that you have these notes on that blank piece of paper to the left of Unit 7, Lesson 1. Make sure you watch this video. And before I go further, I'm going to talk about the secant of angle B here. And I'm going to use this definition right here. What the heck is the secant of angle B? The secant of angle B is going to be the hypotenuse again, divided by the adjacent side. So this kind of time it's going to be C over A. Okay, there's one more trigonometric ratio we're going to look at here, and this is going to be called the cosecant. And this one is abbreviated CSC of angle A. And the CSC of angle A is going to be the hypotenuse divided by the opposite leg. So I want the cosecant. Let me zoom in just a little bit. I guess I would be zooming out. I just want to zoom in out just a little bit. Yes, so I can see this. I'm looking at the cosecant of A. And the definition is the hypotenuse divided by the opposite leg. Well, we know the opposite leg to A is going to be this little a. So that's going to be C, which is the hypotenuse over lowercase a. And it's interesting to note that the cosecant of A is the same as 1 over the sine of A. And as we've done, let's go ahead and find the secant, pardon me, the cosecant of angle B while we're at it. Cosecant of angle B. It's going to be the hypotenuse again, which is C, divided by the opposite. The hypotenuse divided by the opposite leg to B, and the opposite leg to B is going to be lowercase b. Dokie. All right, let's do an example with these rascals. Here I have a right triangle with one leg of 5 and one leg of 11, and I want to find the secant of angle B. Well, the first thing I'm going to do, and we know that that's what I need to do, is I'm going to, now I think I'm going to zoom out. Yeah, I'm going to first and foremost use the Pythagorean theorem and know that c squared is going to be 5 squared plus 11 squared. So c squared is going to be 25 plus 121. So c squared is going to be 146. Therefore, c is going to be the square root of 146. This guy is already simplified. It has no perfect square factors in it. So that guy here is 146. And I want to find the secant of B. The secant of angle B. I want the secant of this angle right there. Secant. Well, I'm going to have to use the definition. And the secant of an angle is the hypotenuse divided by the adjacent leg. The hypotenuse divided by the adjacent leg. Let's see here. To be, well, the hypotenuse clearly is square root of 146. That was horrible. And the adjacent side to B is going to be 5. And by golly, that is the secant of angle B. While we're at it, why don't we find the cotangent of angle B? And the cotangent of angle B, I need the definition for cotangent. And the definition, I'm going to walk up here and look for the definition. Oh, okay. The definition of cotangent is the adjacent leg divided by the opposite leg. Let's see here. The adjacent leg divided by the, ooh. I believe the cotangent of B is simply 5 over 11. And while we're at it, why don't we just find the cosecant of angle B? Cosecant of angle B, I need to look at the definition. The cosecant is the hypotenuse divided by the opposite leg. Get out of there, get out of there. The hypotenuse, which is 146, divided by the opposite, which is 11. And that's a cosecant of angle B. I think I'll put him in here. I believe this guy here, the cosecant of A. The cosecant is going to be the of A. Now I'm looking at angle A is going to be 146 divided by, oh, let's see here, the opposite of A, which is 5. And it is certainly interesting to note, and we'll talk more about that, that the secant of an angle is the same as the cosecant of the complementary angle to that. So and that you won't need to know this connection for a while. That's going to be down the road. So let me zoom out here a minute. And we'll zoom out to the entire page. So I've got the definitions of cotangent, secant, cosecant. Pause the video and zoom in on that. What else did we talk about today was the formal definition of sine, cosine, and tangent. All right. So this is a little 25-minute video. Please take notes on this video. You're going to have to. We're going to look at this new page that we added to our Unit 7 lesson. This guy right here. And we will continue with this discussion the next day. All right, so we're going to stop the video here. We will see you shortly.